says write if it's positive, negative, or no relationship. So we're just looking at the graphs and we're deciding if you could draw a line of best fit in. Remember, a line of best fit just goes in like the middle of all your data points. Okay. You want about the same amount of data points on both sides if you were drawing it in. Now, if you could draw it in, if it's a positive slope, a negative slope, or if you can't draw it in, then that would be no relationship. So number one, can I draw a line in there? No, so then that's what? No relationship. Okay. Number two, could I draw a nice line of best fit in there?
Yes.
Yeah, and what kind of slope would that?
It is going downwards.
It would be a negative slope. So go ahead and finish the page. I draw in the line of best fit just so I can see it. You don't have to. Okay, so go ahead and finish the page. Finish through 6.
What was number 2?
Number 2 was negative because it was going downhill.
I just write negative.
Yep. So positive, negative, or no relationship is the answers, possibilities on 1 through 6. Okay. So everyone should be on the second page when you're done with those. Make sure you get enough time here. So the second page actually has the exact same graphs, but now they're asking you to do something else with them. Yeah, so I'm glad that you noticed that because a lot of people don't notice that they're the same graphs. It says explain the relationship. So we actually have to explain in words the relationship between the variables in the following scatter plots. So we need to use words. So in this one, was there a relationship here? No, so I need to literally say that in words. There is no relationship between, what are my 2 variables in this graph?
Types of rain and time.
Yep, time of day and rainfall. Yep, between time of day and rainfall. So make sure you're writing this down. And I want that complete sentence. So I do want the period at the end. I do want the capital T. If you started with there. Okay, it's good just to keep that consistent in all of your subjects. Okay, are we good on number 1? So let's look at number 2. What are my 2 variables here? Average daily temperature and coffee sales. So what's happening to my temperature as I go this way on this x-axis, if I go to the right? It's going higher. So the average temperature is increasing. What's happening to coffee sales during that time? They're going down. So we need to say that. So we need to say as the average daily temperature increases, the coffee sales what?
Decreases.
Yeah, decrease. Now you can word that any way that makes sense. Okay, so like obviously you don't have to have the exact same words as me. Just so you can say that like coffee sales decrease as temperature increases. You could say it vice versa. Okay. So go ahead and finish this page. Now, a lot of times people struggle with this because they said, well, that graph doesn't make sense. You use the information they give you. So you might not believe this as a true statement, but that's what the graph's showing you. So that's what you're going to say. Does that make sense? How I'm saying that, like, you might not think that coffee sales decrease as temperature increases, but that's the information you have. So you have to say whatever they give you. So go ahead and finish through 6 on that one. All right. All right, so you should have done 1 on your own. Now number 2, so you're looking at that line of best fit, okay? So that line of best fit is literally the line they draw like in like the middle of all your data points, okay? So that's like the trend line. Sometimes they'll call it that. So that's the way it's going, okay? That's the way it's trending. According to the line of best fit, how tall would a 14-year-old be? So you need to look at 14 and see where your line of best fit is and answer that question. Okay, so at 14, where does your line of best fit hit? Okay, so go ahead and circle your answer on that one. Okay, then number 3 says which of the charts would be the most useful in predicting. So which one has an accurate line of best fit is really what it's asking. So if you want a prediction, you got to have that line of best fit. So pick your correct choice on that one. Which one has the correct line of best fit? So that'd be a good prediction, good trend. Okay, number 4 you can do on your own. Go ahead and do number 4. And then I want you to try number 5 and number 6. And I will talk about number 5 in a minute, but I want you to get answers for both. Okay, so I'm going to leave you alone for a second. Okay, so what did you guys come up with on 5? Was it a positive, negative, or no relationship, or not enough information? I would accept both C or D on this one. Okay. I don't see a relationship here, but I also see that there's really not a lot of information. So I would accept either one on that. Okay, number 6 you should be able to do on your own. So let's look at the next page. So this is talking about correlations and causation. So a correlation is just a relationship between 2 things. Doesn't have to actually make sense. There can be correlations between anything. So like when we have the graphs, so let's say when we have these graphs here, there was a correlation. They're saying this is the correlation between time of day and rainfall, but there wasn't a relationship there. Okay, there's just a comparison of 2 things is a correlation. Now, the other thing is called a causation. Okay. Okay, causation. Causation literally means to cause the other one to happen. It has to cause the other one to happen. So on number 10, the more electricity is used, the more ice cream is eaten. Does that one cause the other one to happen? No, right? Like just because I use more electricity, does that mean I'm going to eat more ice cream? No, that doesn't mean anything, right? So this is just a correlation. It's not going to cause the other one to happen, so it's not a causation. Okay, so all of these are correlations, but then there's a special case where it's a causation when one has to have the other happen. So the more gifts are given, the more carols are sung. Does that cause the other one to happen?
Maybe.
No. So correlation. I know some of these are hard because you could kind of come up with an argument. So like on 12, if you eat fewer sugary foods in general, would you usually get fewer yeah, that would be a causation in my opinion. Okay. So finish this 10 through 15 and then the 1 through 9, because those are both just causation correlations. Okay. Okay, so then the bottom here, it said like, give an example to make it a causation or a correlation. So what they want you to do here is like compare something against a student's height. So you could like say a student's height with their age. Now, would that have some kind of causation to that? Yeah, like usually, okay. But what I'm not actually going to make you do that. I just want you to understand what they were asking you to do there. And remember, anything can technically be a correlation. Just a causation is a little different. So if we're looking at the back side, okay. Number 1 said the following situation, for the following situation, determine if there's a correlation. And if there is it a causal relationship? That does not say casual, it says causal. So that means like, does it cause the other one to happen? Like a causation, okay? So it says the number of hours practicing at the batting cages and your batting average. What would you hope would happen there? You would hope that it would be a positive, right? Okay, so we already down to B and C. Would one cause the other to happen? Yeah, you would hope the more you practice that the better your average would get. So C. Okay, these are very important to pay attention to. Just gonna tell you that. Number 2, we haven't talked about some of these words. It says when evaluating data on a scatter plot. So remember, we have all those points on a plot. What can be used to make predictions about the future? So we have that trend line, right? And if it's something in the future, it's not on my scatter plot, okay? Well, this has nothing to do with correlations and causations. That's not what we're talking about. So we're gonna get rid of those. So 2 words we haven't seen yet, but we can dissect the words and see what they make sense to be. Interpolation. Inter, like internal. What does that mean? Inside. Is it inside that graph if you want to make predictions about the future? No. Okay. How about extrapolation? Extra, outside of the graph. Does that make sense if you're trying to make predictions about the future? Yeah, extrapolation. Okay. So if it's making predictions, it's not on that graph, it's outside of that graph, extra. Okay. Number 3. Mr. Bolton worked for the same company for 17 years. Yeah, it can be. What relationship would you expect between the number of years that with his company and his annual salary? What would you hope? You would hope it'd be a positive relationship, right? Because you would want that to completely increase. If not, he probably should look elsewhere for a different job. Okay. Number 4. A city had a population of 150,000 people in 1990. A population growth of the city is represented by this equation, P equals 5T plus 150, where P is population in thousands. Okay, that's kind of important to remember. So they're saying in thousands, that's P, and T is the time after 1990, years after 1990. Okay, in what year will it have doubled? Well, how much is it right now? 150,000. So I want that to double. So what do I want that to be? 300,000, right? So I want to get to 300,000. That's my goal. But remember, P is represented in thousands. So P, I would want not to equal 300,000. I'd want it to equal what? If it's in thousands, it would be 300, right? I essentially just get rid of the thousands because it's in thousands. I want P to equal 300. Well, if I want P to be 300, let's plug that in for P. I want P to be 300, so I'm going to plug it into this equation. I'm going to put 300 instead of that P equals 5T plus 150. Can I still solve for that variable? Yeah, what do I need to do first? Move that first, right? How do I move that? Subtract that 150, love it. 300 minus 150 is 150, equals that 5T. Now what do? Divide by 5. So T is what? What's 150 divided by 5? 30. Yeah, T is 30. So 30 years after what? What was T?
2020.
So 30 years after 1990, yes, which would be 2020. It was, apparently. Okay. So a couple like key things to take away from that. It was in thousands. You always have to check your label here, because if you would have set that equal to 300,000, you wouldn't get the right answer, right? You'd get a huge number. Okay. And then T was after 1990. So you got to figure out what to do with this 30. Okay. You have to read those little things. Okay. Number 5, this graph. What do you see here? What kind of relationship?
None of the
Is it either, well, so is it none of the above? Could I make a trend line in here?
Yeah.
I could make a trend line, so I'm not gonna say none of the above. It would kind of, does it look negative to you? I see it's down, I see it going down a little bit. So I would either accept, no correlation also on that one, yeah. I see negative because I see it going down, but I would accept both of those. Okay. Sometimes you're going to be asked to make an equation of a trend line. So essentially you're going to make a line and you're going to come up with the equation of it. And I'm just going to draw my trend line in as well as I can. Okay. You know your favorite equation of all time is y equals mx plus b. Okay, so in that equation, I need slope and I need my y-intercept. Well, my trend line, when I drew it in, where did I cross the y-intercept at? Approximately. About 25. So my b is 25. Now, the other thing I need to figure out is how many my slope would be. So if you ever get a question like this, it's going to be on a test that's like a multiple choice. Okay, so you just have to get close and then see which answer makes the most sense. So you can figure out how much up and over from one point to another. Let's go from, that's approximately like 51 to 61. So how much did it go up every hour? About 10. I would say about 10. So I would say about y equals 10x plus 25. Now remember, your equation might be a little different than someone else's, but that's approximate, okay? What would the earnings be for 40 hours worked? So a couple different ways you could do that. You could put the 40 into here, right? Into your x, into your equation. Or a lot of people like to look at your graph and say, okay, well, if I worked 5 hours, I made about 70 bucks. So if I worked 5 hours with $70, can I figure out how many 40 hours would be? What would I do? How many groups of 5 to get to 40? 8. So how many groups do I need here? 8. What's 70 times 8? 8 times 7, add a 0. 560. So approximately he made 560 bucks. I wonder how close that is if we put in the 8 here. Well, oh, we're 40. Yeah. So what's 40 times 10? 400. So then approximately 425 on that. So remember, our equation and our stuff are a little different. So there's going to be a little bit of leeway there. It matters what your trend line looks like. So I would accept anything from 425 all the way up to 560. Does that make sense? To like interpret a graph? Awesome. Okay, so